Hello everyone, welcome to the Learning of Engineering Tutorials video lectures. In these video lectures, we are trying to learn what is the strain energy stored in a body when the load is applied with the impact. In previous video lectures, we have seen gradually applied load and then how much amount of or what is the magnitude of the strain energy, and when suddenly applied load, what is the magnitude of the strain energy we have calculated. And now we will see the impact load is going to come in. It is very clear that impact load means it possesses certain kind of the velocity while hitting the final object. So for this one illustrated diagram I have presented here. So that's going to be, one is going to be your vertical rod I have taken, and this is going to be the collar, and the hatched one is going to be the load, and it is located at a distance of height h, right? And then once if I am going to be relieving from this position, so then what will happen, it is come and strike the collar, and this is going to be the deflection of the system or displacement of the system. So that's going to be del L. Now we need to find out the sigma value, how much it is going to be, because we know the strain energy is equal to sigma square by 2E into the volume of the object. In gradually applied load, the strain already we have calculated, that's going to be P by A. Suddenly applied load, that's going to be 2P by A we have calculated. So this is going to be gradually applied, this is going to be suddenly applied conditions. Now it is going to be the impact conditions that we need to be calculated. So first of all, I am going to be considering here is the del L, right? So del L, how we are going to be considering, that is, we know the strain is equal to change in dimensions to the original dimensions of the component. That's going to be del L by L. So del L is equal to epsilon into L. As we know, the strain I am going to be writing in terms of the stress as well as the strain. The epsilon is equal to, the strain is equal to the stress by Young's modulus. That I am going to be substituting here. That's the del L is equal to sigma by E into L we are getting, right? So once we are going to be getting this one, I can use it in next level of in this equation. So now we got it. What is the del L? How much amount of the elongation that we define in terms of the stress as well as the Young's modulus. Now I am going to be considering the work done by the load. We know the work done by the load is equal to, that's going to be P into H plus del L, right? So this is the distance that load has traveled from this position to this position. So that's why I have taken WD is equal to P into H into del L. So then del L I am going to be substituting in this equation, right? So then this is going to be the strain is equation, this is going to be the one, and this is the second equation, right? I am going to be equating 1 is equal to 2 so that I can derive the equation. Now we equated equation 1 as well as the 2. So this is going to be sigma square by 2E into V, then P into H into del L, this is going to be the displacement. Now del L is equal to sigma by into L. I am going to be simplifying this equation, that's going to be P H plus sigma by E into LP I am going to be writing, and this side that is equal to sigma square by 2E, the volume I am going to be writing area into the length. And further simplification of this equation I am going to be taking to the right side over here. So that is equal to the sigma square by 2, so that's sigma square AL by 2E I am going to be writing, plus here the sigma into LP by E I am going to be considering, this is going to be the minus we are getting, minus PH is equal to 0, right? Now I am going to be taking this terminology towards the right side. So that means I am going to be multiplying with 2 by E divided by A. So that 2E by AL I am going to be multiplying the total equation. So then what I am going to be getting, that's going to be sigma square minus sigma. This is going to be LP by E, and I am going to be 2E by AL minus P into H, then 2E by AL we are going to be getting, right? And further simplification of this equation I am going to be deriving here. So in this equation E will going to be cancelled, Young's modulus, L will going to be cancelled out. So then there is going to be a 2p by A into sigma is available. In this case, the simple equation sigma square minus, so this is going to be sigma into, this is going to be 2p by A minus 2phe by AL is equal to 0. So further simplification of this one, it is going to be representing like ax square plus bx plus c is equal to 0. From this quadratic equation, we are going to be writing that x1 comma 2 is equal to minus b plus or minus square root of b square minus 4ac by 2a, we will get it. Then the same equation I am going to be adopting for this condition. So that in this case, I am going to be calculating the sigma. The sigma is nothing but the stress developed due to the impact load, that is equal to 1 comma 2 is equal to here. So minus b, here minus value is there, minus 2p by A plus or minus the square root of 2p by A minus, that's a whole square, minus 4 into A is equal to, the coefficient is going to be the 1, right, and C is equal to, I am going to be getting here minus 2phe by AL, I will get it by 2 into coefficient here is the 1 we are going to be getting, right. So then what I am going to do, further simplification of this equation. So the further simplification, minus minus will going to be cancelled, that's going to be sigma is equal to, this 2 I am going to be writing individually, that's going to be p by A plus or minus, when the 2 is going to be getting into the square root, that's going to be here 4p square by 4a square minus of, minus minus will become positive, and here is going to be 8phe by 4al, we will get it. And further simplification of this equation, what I am going to do, this 4 and these equations I am going to be taking here, sigma is equal to p by A plus or minus, so this is going to be p square by A square plus 2phe by AL, right. So in this case, p by A and p by A common is there, that I am going to be writing to the next side. So that's going to be sigma is equal to p by A plus or minus p by A square root of, this is going to be 1 plus 2ph, p already we took it out, he by AL, this I am going to be taking A by P, right. So then, so in this case, A already we took it to the outside. So then the sigma is equal to P by A plus or minus P by A square root of 1 plus 2E AH by PL, we will get it. So if I am going to be taking the P by A also common, so that's the sigma is equal to P by A 1 plus the square root of 1 plus 2EAH by PL we are getting. So once we are getting the sigma value, that's going to be P by A this value. So then we can substitute in your strain energy. The strain energy is nothing but sigma square by 2E into volume of the object. This parameter we have calculated. Then substitute in this equation, right? Already we have calculated for the gradually applied load, suddenly applied load. Now it is going to be the impact load. In these conditions, what will happen? There are going to be two parameters, suppose I am going to be considering here. One is going to be H is going to be greater than del L, suppose. So then what is the condition? So the next condition is I am going to be considering H is equal to 0. If these two conditions I am going to be substituting in this equation, what I am going to get it? So when H is going to be your first condition, H is greater than WL, so this is going to be negligible, right? So that equation, how I am going to be writing, we know the work done is equal to the work done that we have taken, that's going to be P into H plus del L we have taken. Now this del L will going to be 0, that I am going to be writing P into H, right? So we know the work done is equal to the strain energy of the system. So that I am going to be equating. So that's going to be strain energy is equal to U sigma square by 2E into volume. So that is equal to work done is equal to P into H. So now equating these two, I am going to be getting the sigma value over here. Alright. So then how much you are going to be getting the sigma O? So that's going to be sigma is equal to sigma square is equal to 2E PH divided by A into L, suppose if I am going to be taking. Right, this is the equation we are getting. So then what I am going to do, I am going to be taking only the sigma value. So then I will get this magnitude. Right, that's going to be sigma is equal to square root of 2E PH divided by A into L. So this way we are going to be calculating when H is going to be greater than del L. If in the another case H is equal, this is going to be your second condition, H is equal to 0. So then what will happen in this case? H is equal to 0 means, so that the finally we are going to be taking in this equation, that's going to be sigma is equal to, H is equal to 0 means this parameter totally going to be 0. Right? This is going to be sigma is equal to 2P by A, I will get it. Right? So when this is going to be the completely 0 means here the square root of 1 1 plus 1 is equal to 2, that this parameter I will get it when H is equal to 0. So now I hope you are able to understand when the parameters of this height as well as the extensions are going to be varying. So we are going to be getting the different kinds of equation. So this is equation is equal to, when H is equal to 0, then we are getting the suddenly applied load stresses we are going to be getting. Right? When del L is going to be neglected, there is no elongation. So then this is the magnitude we are getting. Whatever the values we are calculating, we are substituting again into the strain energy, and then we are going to be calculating the magnitude of that. So still, if you feel any confusion or if you are not able to understand, please put in the comment section so that I can reach you out. Thank you.